Hi, welcome to this session of the Open Security Summit sessions in March 2021. And this is actually a very exciting session because it's going to, be talking about, I think, a new sort of a recent, tool that, Tudor is going to share with us called the Moldable Development with Glamorous Toolkit. And so what is the Glamorous Toolkit? Is the toolkit that we're going to be using. And I feel that it has a huge potential for security, to allow security to scale. So we actually have 3 sessions this week, which is really cool. So today's session, I think, is going to be a lot about Tudor showing us around the tool. And everybody, of course, please ask questions and see how it goes. But it's about us almost seeing, how to use it, how to get the best value of it, and some use cases. And then tomorrow, and I think is Thursday or Friday. Thursday, right? No, Friday, sorry. And then Friday we can continue the conversations also on the security elements of it. So over to you, Tudor.
Well, thank you. Thanks for the introduction. My name is Tudor Girba, yes, and I'm the CEO of Feenk. Feenk is a company that is focused on making the inside of software systems explainable, and that's like a tall order goal. And until now, we have contributed 2 things to this end. On the one hand is a new way of programming, which we call moldable development. On the other hand is a practical toolkit where people can actually use and put in practice the more theoretical parts of it. So the presentation today will be focused mostly on the toolkit, and then I'll be exemplifying how this one works for various types of situations. So what is Glamorous Toolkit? That's the toolkit that you have right in front of you. We call it a moldable development environment. It's essentially a place with which you want to build your own tools specifically for your own problems. Now, why is this at all interesting? That's because developers spend most of their time figuring the system out. That's what occupies most of development time, and most of this time is actually spent on reading a lot of text. So, and that's interesting. But on the other hand, it's very rare that we see developers actually talk about how they read code, or how they go about figuring the system out. And we were thinking, well, given that this is what occupies the most of the development time, then perhaps it's more interesting to focus and optimize for this activity. So, because when we are saying most of it, we're talking about 50% or more of the time. And if we don't talk about something, it's not explicit. If it's not explicit, it has never been optimized. And so going around and spending the largest chunk of our time on something that has never been optimized, it's not, it's perhaps not the best thing we can do. So that's the problem. That's the problem space. Now the question is, how do we do it? How do we solve? How do we, rethink this space such that we can optimize this part? So the reason developers read code. So if you go here, this is a slideshow, and I'm giving this slideshow right in the development environment. Because so when we're talking about development, right, we're talking about just the largest chunk associated with the active part of creating, but most of our time is actually, a good deal of our time, most of our time is actually not being spent. We're not spending in creating anything. We're spending it figuring the system out. And the reason we spend this amount of time is because we want to reach a decision. So from this perspective, we're actually looking at software engineering as being primarily a decision-making business or a decision-making activity, rather than a construction activity. And that's quite interesting, especially, for example, if you look at in the security space, a great deal of problems in security are not how do you construct necessarily things, but how do you understand what's going on and how do you react to those. And those are much more interesting. It's much more interesting to optimize for this from a decision-making perspective rather than from a construction perspective. But equally interesting is that the same kind of thinking applies to all other parts in software development. And that's the part that we optimize. Now, how do we do that? Well, if you look at it from the decision-making perspective, the way you gather the information, as I said, usually that is being spent on reading, the way you do that is just the technique in which you gather information out of data. Because everything about your system is data, including your source code, your data in the database, your log files, your configurations, your everything is just data. And reading happens to be the most manual possible way to extract information out of data. And we're spending the largest chunk of our budget doing exactly that. So perhaps we can do it differently. Now, how differently? So here, when you open Glamorous Toolkit, there are a number of resources that you have available. So one of them is the tour. And the idea here is to present what Glamorous Toolkit is. Yeah, that's our company. Glamorous Toolkit has actually a significant amount of history behind it. It's now more than a decade in terms of the project. And this is the second generation of the technology that we have created within Fink. And when we started, we spent most of the time of rethinking this. How do we approach, how can we optimize this decision-making time that we spend during development? We spent most of the time for over the last decade focusing on a rather simple problem. And that problem was, how do we change how we relate to a single object? So not the large thing, not how do we fix the maintenance problem and the architectural problems in multi-million lines of code legacy systems. We can do those, but that's not what we focused on. We focused on the smallest possible unit. And why the smallest possible unit? Because in software has fractal-like properties, which means that patterns that you see in the small, you will also see in the large. So if you want to solve large problems, you should probably start from the smallest possible problem in that space. And that's why we started from just looking at a single object. So what do I mean by that? Well, so here I have 6 different objects. So 1, 2, 3, 4, 5, 6 different objects. And if you think about, how do you reason about existing objects? It's you do it via a tool called usually an inspector. So an inspector is one of these tools that shows you, like usually the inspector is defined as being the tool that shows you the inside of an object, right? So then what is the inside of an object? Well, these are the variables and the values. And so all these inspectors will show you exactly this: variables, values, variables, values, variables, values, and so on. And that's interesting because now we can apply this tool to absolutely every single object in the world today, and it will work. It will show us things about the inside of that object. Now, it's because the tool is so generic that makes it completely uninteresting. What do I mean by that? Well, if I just look at these ones, there's not much for me to distinguish here, right? I can see, okay, these are three parts here, but here's more, but that's about it, right? So if I stay half a meter away from it, I can't distinguish anything on the screen. And that's interesting, right? Because if you think about what makes value is always contextual. Value is not a generic commodity. So so from that perspective, right, if instead of looking at it like this, I do this instead. I take those exact 6 objects, and now I'm showing you them. I show you them, the same objects, but through a different view. And all of a sudden you can say, okay, that looks like a fraction. That looks like a folder. That looks like a picture. That looks like a Bezier curve over here. That looks like some sort of a geometric algorithm. And maybe this looks like a data structure. And you do this in a second, right? Or less than a second. You do this almost instantaneously. The only thing we have changed here was just the shape of the object. We just changed how we're looking at that, what the thing that we're looking at. We didn't change the content. We didn't change the system. We only changed how we look at it. Now, given that this change can elicit completely different types of, or both qualitatively and in terms of speed, different responses, it follows that the shape of those objects, the shape of the tools through which we go and experience our systems, they are essential. This shape is not something to overlook. It's not something to take for granted. But instead, we want that shape to be as specific as possible, both to the thing that we look at, and more interestingly, you will see a bit later, also to how to the question that we actually have at present time and that we want to make a decision about. So if we learn this, the other thing that we learn from here is that there is no single decomposition of a system. There are always many, right? So just because this is a view, which is a reasonable, it's a valid view, this is also a view about their different objects, which means that there is no single perspective that should be hard-coded in a tool. And that's the very idea of moldable development, and that is that the environment should host the perspectives that we deem important or interesting about what we're looking at, rather than the other way around. So if we go more concretely here, we have our 6 objects over here, and we have different views here. This is the raw view, this is the preview, this is how an inspector looks like. And this is a file reference pointing to a folder, this is a file reference pointing to a picture. Now, interestingly, these are file references, both of them. But this one points to a folder, this one to a picture, right? If we look at the path here, both of these views make sense, but of course, the items doesn't make sense for a picture, or the hex doesn't make sense for a folder, right? So the inspector kind of knows how these things work. So the other thing here, we have an element which is able to draw itself. In this case, it's a Bezier curve, and some looks like here like a circle, graph circle, neighborhood object that knows how to depict some algorithm. And this is a piece of text that we can see in many different ways. So anyway, that's the idea. The idea is we want an environment that simply can host many different perspectives about anything we have in the system. So not just about simple things, but anything we have in the system should not be governed by a hard-coded perspective. So, okay, let's do something concretely here. Let's open a playground. And in this playground, let's say we're gonna go and browse the file reference. So we're saying here, I'm now writing here pharo code. So Glamorous Toolkit is implemented in pharo. Pharo is a Smalltalk system. And Glamorous Toolkit adds a new kind of a new graphical environment on top of that. So here we're having the dot, and then we say we're sending to this one, we're sending this message as file reference. Interesting, notice that triangle over here. So if I expand that one, I can see, okay, this method is as file reference is implemented in the class string. And I can see that basically it says file system disk reference to self, so this specific string. So I will be getting the file reference pointing to the current folder. So that's basically what I see. So what happens here? Now, well, here it happens that I'm seeing a file reference to the folder, and the folder, of course, shows me the tree or the items. I can also see it as a tree here. And so then here I can go in there, I can go and navigate in that tree. So let's see. Okay, here I found the actual folder that contains the sources for Glamorous Toolkit. So Glamorous Toolkit this is a Smalltalk system, which means that it has an image, but the image is actually produced by out of sources, and those sources are actually shared via GitHub in our case, or hosted on GitHub. And so this is a Git repository for this. Okay, so next here we're seeing, okay, I have here a doc, and all of a sudden here I see, okay, there are some PNGs over there. So this is a PNG, this is another PNG, and another one. So again, like, what's the name of this tool, right? One of the things we can ask. So here, this was a playground. This is how we call this one, but you can think of it as a REPL, where you can just, or as a notebook, where you can just type things and get some inspector on the right-hand side. But this is now an inspector, but this inspector actually serves the purpose of a file browser here. So, and up to now, right, I could just go and navigate. I can kind of reproduce, for example, a the utility of a file browser, but I do it by composing just a couple of inspectors around. So that's kind of an interesting thing. But what can we do with it? So let's go back here. And there's another folder here called Zooniverse. Now, Zooniverse is just a mobile app. It's a React Native application that 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 we use as a case study. So here I can see that there is for example, a package.json. Okay, so now I have a package.json over here, and there I can see, okay, these are dependencies in that package.json. Okay, which is nice. So now let's quickly let's simulate. So it's interesting over here. I was in a file browser, but now I'm in an editor, and this is just integrated there. I can actually go and type things, and it has syntax highlighting as you would expect. But more interesting is, let's say we were talking about decision making. So let's simulate now a question that we might have about a package.json. So here it says, okay, these are dependencies that we have. What do we do? Let's say this is a React Native application, and say that we are interested in all the dependencies that are not React Native, right? So because this is based on this technology, let's no longer use. Let's not care about those the dependencies that come with the framework. Let's just use just be interested in the system specific dependencies. So how would we go about doing this? So one way would be to say, okay, maybe we copy this somewhere and we kind of filter things. But that would be, treating this one as if it's text. But this is not text, this is JSON. So if it's JSON, what we should be able to do would be to simply say here, well, Stone, I'm going to say, so here if I say self, that's self. This is a playground for this object. This self means this file reference. And if I say here contents, it's going to give me a byte string that if I look at, it's just the string over here. So, which is nice. And now what I want is, of course, I don't want to see text here. I want to see the actual structure of this. So I'm going to say stone from string. And so stone is a parser for JSON in this case. And when I parse these contents, what do I get? Well, I get a dictionary, or in Java it would be a map. So this is like a key values, and I can see, okay, here I have the dependencies. If I look in there, I can see, yeah, indeed, these are the keys and these are the values. So maybe even here, I could just extend my little script here and say, well, I want the dependencies, just the entry, the value of the dependencies key. So I will get a dictionary with 400 items there. Right, that's what you get here. And okay, so maybe from here, we just want to see here, I want to get all the key values. So I get all those key values. Now I have an array. And from this array, I'm now going to select it, where I'm going to select those for which the key begins with React Native. And begins with is not understood, so begins with, that's better. And if I'm executing that, now I have those. Okay, these are the 21 that are React Native, but we are interested in those that are not from React Native. So we're going to reject those that are React Native. So I have now 19. So now I answered my question. But what's interesting again here is that the question was answered. The question was answered by constructing a tool that was specific for that question. Very much how we have, for example, data science is like that. Is a data science starts with a question, and then you're going to build the analysis for that question, and then you're going to take the answer and you're going to play with it. So if we go here, right, we're going to do exactly the same thing. We start with a hypothesis, with a question, and then we're going to say, okay, I'm going to apply a tool. I'm going to take the results, and if I'm confident, I'm acting. If I'm not confident, then I'm going to repeat. But of course, now the interesting part in software is that software is highly specific or highly contextual. And because of that, we cannot actually predict specific tools that people will need. We cannot predict specific problems people will have. So as a consequence, we cannot provide clicking tools. The only thing we can predict are classes of problems that people will have. And as a consequence, those are best served through some programmatic means. And the same applies to the IDE. The IDE is a tool through which people should be able to answer questions. By the way, the I in IDE stands for integrated, which means that by that definition, every time you're going to do something about your system, but leaving the IDE, then the I has failed. And we do not want to fail. We want to stay right in the IDE and be integrated with everything, with all means of expressions and all needs related to decision making. Okay, so then how do we address that problem? Because up to now, this one looks like a scientific method, which it is. But again, like specifically for software, we have to ask this question. What happens? Do I actually have an appropriate tool? Because if I don't ask that question, I will just do the most natural thing that is in front of me. So for example, if I see text in front of me, I will tend to read it because that's what I do with text. But if I'm gonna say, well, is text actually the appropriate, is reading the appropriate tool right now? Is that what I should do? And if the answer is no, then maybe I should go and build that tool. If I don't have an appropriate tool, I want to mold that tool. And that's what moldable development is. And so Glamorous Toolkit is there to help us create these kinds of tools as on the fly, basically, while we are working on the problem, right? So that's exactly what happened here. We were in a tool, and then we took a little bit of time to construct another view. In this case, it was a query, so that we to answer our question. Are there maybe questions so far? No, must be that I'm explaining very well. Okay, so the people are actually saying that I am explaining very well. Okay, that's good news. Excellent. So let's move on. So up to now we've just answered some kind of a question. Now we can go a little deeper there and say, well, how many types of questions can we handle using or following this type of interactions here? So for example, here we're having JavaScript. So if I go there and I see, okay, this is JavaScript, right? And I maybe take a look at this line like that, or these are some utils in JavaScript. Maybe here there is some, I don't know, annotation utils or some other files, right? I can go and browse them, and I have a JavaScript editor over there. So that's kind of interesting. Now here's a bit of a longer one. Now let's say that you want to maybe write a lint rule, right? A JS lint rule, but for JS to write that lint rule, you need to have some understanding of the inner structure of the how the language is represented in this case, and this is JavaScript. So you will want to go and reason about the abstract syntax tree of this. So how do I go about doing this? Well, again, this looks like text, but it isn't text, right? It's a language, it's very structured, and because it's a language and we know it's a language, we're going to do exactly the same thing that we've done with the other thing. It's like the form is not good. We want to change it. So how do we change it? Well, I'm going to take a JavaScript parser here, and I'm going to parse the contents of this file. And what do I get? Well, I get, in this case, I'm not going to get the dictionary or the nested dictionaries, which is the representation of JSON. I'm going to get the abstract syntax tree of JavaScript in this case, and that's what I will be exploring. So what you're seeing here on the left is the abstract syntax tree of like the source code, and on the right you see the abstract syntax tree. So now if I'm clicking here, I can see how that one maps on the right on the different parts of the AST, and this is basically how I can recognize different patterns. So basically, at the end of the day, all of these languages that you're facing, they're just some data structure behind it. So if you want to now do some static analysis, there's nothing but all static analysis is simply traversing this data structure and searching for patterns. And what's interesting here is that you're doing this all day long, like all developers are. That's pretty much what systems do. They take some data, very often coming in form of a tree, and they build models out of that. And we then manipulate those, we transform those, we measure those, and we present those for what? For humans, other humans, our users. For humans to reason about systems or to reason about data without the users ever seeing the raw data. And that's a magic skill we possess. All developers possess that skill because that's pretty much what we do. And it's a very interesting skill to have, to transform, data problems into information problems. The only thing we should, still left to do is to utilize that magic skill for every single one of our problems. That's it. And that's what moldable development is. It's a complete departure from what typically happens today. But that's because just what typically happens today is, not appropriate, actually. Okay, so this one. Now let's go a step further. So this is a React Native application, as I was saying. And up to now, we were just looking at trees. Now let's go, a step further here. And so here, we're going to take the same thing. And we're going to say, okay, this is the Zooniverse thing. This is the Zooniverse folder. And there, I will now take a little bit step further. So instead of just saying, I want here are the trees of data, I want to now see connections in that data. So we're going to now, parser gets sources, for example, or some representation and gives you a tree. And you typically want to take that tree to build a graph out of it. That's what typically happens with pretty much all data that you're facing with. And that's the same thing we can do with software too, to the extent we can. So what do I mean by that? So here I built a model out of that, out of this React application. And in this model, we can have classes, we have functions, so the functions in JavaScript, and we can see those functions over here. And right, so if I go to, let's say, this one, we can even see the source code, and we're going to see where it is. So now that's the source code of this function. But we can also see other kinds of things. For example, we can see how how the variables and so on. And what's more interesting, as I was saying, this is a React Native application, which means it is made out of components, or React components. Now, React components are actually a construct on top of JavaScript. And if you think about it, so let's take a look at one of these React components. I'm going to click on this React component. And this one shows me the construct of it. So basically here we see this is the name of it, shape instructions view. And this one has a return. And it's going to return a view, and then it's going to use a shape preview over here, fonted text. These are different components, other components that are being used. Now, what's interesting here is that indeed this is JavaScript, but the semantics of React, if you just look at this piece of code as if it's JavaScript, you're going to miss pretty much most of the interesting parts of this code, right? So, okay, just disregarding the fact that JSX is another embedded language there. But there is a way to, so in order to reason about this code, you want your tools to also have a higher level of abstraction. You don't want your tool to just understand JavaScript. You want your tools to understand React. Now, one of the problems that appear reasonably often, or we found out by just playing around with the mobile app, which were just playing around with React Native, so we built a mobile application. And within a couple of weeks, we learned that we stumbled across this, the cyclic dependencies between components. And we then looked, okay, so there must be some tools around that will help us make sense of dependencies between React components. And yeah, there probably are, and most of them have some textual representations there. But then we said, well, that's a problem that we want to solve, because a tool like that should not necessarily cost a lot. So this is why we constructed this kind of this JSX analyzer. And so here for this group of React components, there is another tab here, so another view. So instead of looking at it like a list, I might want to look at it like this. And so what's interesting here is that I can see the dependencies, I can see the components, and I can see their dependencies. So if I click, for example, on render button here, it shows me the source code of that component. So I can see the render button is actually returning a button, and that's why I see a dependency from render button to a button here. And that's it. It's that simple at the end, right? So now, just again, think of where we are. Where did we start from? We started from an inspector. And then we said, well, that inspector, maybe we can transform it into a file browser, into an editor, into a query tool. Then we transformed it into a model browser of source code. Then we transform it into a visualization, and now into a little visual browser through which we can actually look at and correlate things. And the inspector is still supposed to be the simplest tool that we have in the development environment. And yet it can be that powerful if we put this property in for it to be moldable. So that's one overview, one initial introduction into what an environment like that can be. And the example, the use case that you've seen here is for software assessment. So something that's how do you reason about an existing piece of system or about a problem about a system without actually necessarily reading code. So here we actually didn't read code to answer our questions. We did something else, right? We built a tool that kind of did most of the reading for us, and we just interpreted. And only when we knew why we're going to look at something, only then we're looking at something, but not otherwise. So, because that's basically where the largest waste of reading actually happens. It happens when reading is actually used instead of for the purpose of searching. Because most of the time you're gonna read, or people are reading their way to find the places that are worth being read. And the first part is not a reading problem, it's a search problem. And that's best dealt with by tools. Okay, so that's the idea of Glamorous Toolkit. Now, if we go further in this tutorial, we're going to see here multiple of these. So the question, for example, is what's an inspector made of? So here we can say, okay, this is a view, and there are some actions associated with the object, and okay, that's the header of the object. So in this case, we're looking at an address book object, and the address book has different views, so it can offer multiple of them. So the contact list, circular one, or contact with details like that. And then it can also have different actions. So this is we say that this is an object-oriented user interface, which is you always start from the context, and then you're going to be presented with the interesting operators that make sense in that context, rather than the other way around, right? We do not have there are no global menus, for example, because those global menu will decompose the problem the other way around. You'll say, well, what? And then to say to what? But we want the user interface to actually be composable. We see the environment as being a language made out of visual and interactive operators that can be combined in many different ways for many different purposes. And that's basically the goal, right? We said software is highly contextual. We cannot predict the specific questions people will have. We can only predict classes of problems people will have. So instead, we're going to approach that variability by essentially giving or providing a language through which the concrete environment that I'm using, I will assemble the environment while I'm working on the environment to play with it. Now, maybe to exemplify, so how is this one then implemented? So if we go further here, we're seeing it's the same view over here, but now that's the implementation. So this code over here is the one that defines that this presentation over there. It's actually not that complicated, right? If you think about it, it's just it's a collection, and we see here a columned list, and we have 3 columns. So 1, 2, 3, right? We can see them here. These are the columns there and there. And by the way, this is a live tool. So if I change this thing, then this one will know it's no longer there. And if I add the C back, it will know that it's there. So there's a whole liveliness built into the environment through which we can connect many things to many things. Okay, so so this is pharo code. And what we see here is that this is actually a method called GTViewContextOn, and this is an argument or a parameter defined by this method. And this method resides in the class called GTABAddressBook, which is the class of the instance of this object over here. And so that's the code. We say here column list, we have title, we have what item. So this square bracket denotes a closure. So a block through which we're going to define the input for that column list. And we're going to define here the 3 columns. Now, what's interesting is this. This is something we call a pragma, or an annotation. An annotation that it's because we want to distinguish this method in this class from all the other methods that are not used for the purpose of printing, right? So if you think about it, this is a view method like that. It's kind of like a toString method that takes on a stream as an input, but the stream is not a textual stream because it's the 21st century, so it accepts at least widgets. And because the idea of moldable development is that there is no single representation of an object, it means that we can have many of them. So we cannot hard code the name of the method there. But what we can do is we can denote those methods so that we can discover them. And that's basically what the inspector looks like. Whenever we give the inspector an object, the inspector will actually search for the methods in that object that are annotated with GTView. Okay, now let's actually see how many of these do we have in the environment. So does this actually work? I mean, maybe we have just 10 of these extensions. So now this is another interesting problem, right? We now want to reason about the environment itself, about how many of these extensions there exists right now in this distribution. So here we can say, I'm going to open another playground here, and I'm saying GTView. And now I actually have a little query language. Well, it's not a query language, it's just a little API. We're saying that, well, given this view, give me the pragmas for it. So how is this implemented? This is implemented basically by constructing a little meta object, a little smart object that says this is the search pragmas filter, and we're going to give this pragma for it. So pragma is the name for annotations in our environment. Okay, so if I now execute that, I do get an instance of a search pragmas filter. Now, what's this filter? Well, this filter knows how to present itself. So then it's going to show me a live view. And what do I have in here? Well, here I will have methods. And this is actually a full editor. Now, what's interesting, again, here is that we are having in this environment, right? In this, we have a playground here that we have transformed into a query box. Then we have an inspector in which we are writing text, right? We are writing code. So that's interesting because it's hard to name this thing. It's most of the time, right? If you think about when you need to search for something, very often you might find yourself actually going to a search tool that is only doing search. While here, we've just decomposed that activity into the basic operators that we use for other things, for just inspecting plain normal objects. And because of that, we can start combining them in many interesting ways. So now there's another problem that we wanted to talk about here. We wanted to say how many of these views we have. So now we have a filter. Now it's interesting. Here we have another presentation or another view, which is called metrics. And if I look at that, this one will now give me how many methods are there in this filter. And I can see here, right now in this thing that I'm showing you here, there are 1,270 different methods that define views, so extensions for the inspector in this environment. So 1,270 plugins available right now, pretty much in a stock Glamorous Toolkit. And notice here that the average lines of code per method is 12. So if you take away the upper part, so the name of the, if I look at one of these, right? So this is one line of code, this is another line of code. They're basically 10 lines of content. So it's because we have brought down the cost of creating these extensions, and because you can create these extensions as you work with the system, there's no friction there. That's why this one then enables a new kind of a flow, a new kind of a development flow. And we are literally building tools like that for absolutely every single problem we're facing. We're going to try to build tools or follow that flow for all problems we're working on. And it doesn't matter whether those problems are, just analyzing some input data, reverse engineering some API, or just building something with the graphics. All of those things are served by interesting dedicated tools. Okay, so if you now go here at the end of this presentation, there's a visualization over here which says, if it comes up, that shows how extensively these views are actually being used. So this is the actual system, all the classes in the system, and all those that are marked with blue have at least one view, and all those that are marked with red have an example. We didn't get to talk about those that much. Now, once we have these kinds of views, so what we see here is that the reach is very large, which means that this principle is actually applicable to a large set of different kinds of cases. In fact, like Glamorous Toolkit, this new generation is the first large use case or case study of employing moldable development for developing a system. And once we have things like that, once we have different views that we can apply to objects, we can start transforming not just how we as individuals reason about a system, but how we communicate our systems to others. So, for example, if I go back here, here we have a domain documentation of Glamorous Toolkit, and that's another component that we have where we can actually, this is a live document. I can go and type things there, so it kind of looks like a notebook with the markup language. And this markup language, what's interesting about it is that the markup only appears when the cursor goes next to it. When the cursor moves away, it goes away. Now, so here, for example, we see a view, and this view is actually showing the dependencies of Glamorous Toolkit itself. So the components that make up Glamorous Toolkit. So from that perspective, right, this is an architecture diagram of these dependencies. Now, what's interesting here also is that if I look at these ones, so if I maybe zoom into it a little bit, I can see that there are, classes over here. So I can click on those. And what happened here was that I am now browsing to this component over there. Now this component over here also knows how to show me a, another document. So, and this document is actually made out of interesting explanations. So this is the document explaining the inspector a little bit, and how this one is made of. And then, of course, from there, we can go and navigate further. So this is now explaining us the playground a bit. But what happened here was that we were in a development environment, and now we just transformed it into just kind of like a wiki, like a live wiki. And because of this, right? So how did we make it? And because we have these views for these objects, we can also start building interesting documents or live documents, which are simply just the composition of, oh, I want that object over there with this view over here, and that's going to be this one. And then I'm going to say, yeah, and then I want that other view, and then I just built a document explaining something over here. So that's the other side of it. Like once we start to be able to express interesting or bring interesting perspectives about the inside of software systems, then we will want to be able to compose those perspectives into larger narratives about the inside of software systems, which then will lead to making those systems explainable. And that is our goal. So I will stop here and I will invite questions for now. Are there questions? No questions.
Okay, also feel free to type your question on the chat in case you don't want to speak. You can type on the chat. Okay, seems there's no question for you, Tudor.
I had a question about the moldable aspect of the toolkit. When we when you create, for example, the view you did with the JSON and the dependencies without React Native and the views of dependencies between the React components, it's just something that's temporary. So after that, in which kind of structure do you save those tools to access them later if you need them?
Oh, so this is, you mean if I would like to now promote that to be a tool somewhere?
Yeah.
Right? For example, here, right? So what did I do here? The way I started first was I said, I'm gonna just do this and I say as file reference, right? And then I inspect this one, right? So this is a tool, a small tool. Now, guys, if you go back here, there are a couple of predefined such entry points. So if I click on that, it will give me a file reference exactly onto this folder, same folder. Okay, so now let's go and find out how is this implemented? Because this is another question, right, that you might want to go and learn about. So I'm now going to press Alt-Shift here, and I'm going to click on that. And now this gives me into a meta place. So it's kind of like an inspector. You can say, okay, look, this one has a button. And this button is made out of various kinds of widgets over here. And like there are many different views. And I'm going to click on the first one because that's the button model. And this one has an action. So this action over here, this is how this one is implemented. Now, what do we see here? Well, we see all sorts of things. I want some helper things. And then in the end, there's an action. And then it says, show me a space, like that's a new tab over there. And then in that space, put an inspector opened on these objects over here. which is very similar to what I just wrote before. And so that's it. So if I, and then this is a method that is stored in a class that I can commit to Git.
Okay. Thank you.
Okay. Are there other questions? Maybe one?
Cool. Okay, any other questions?
Yeah, another question maybe.
All right, sure.
When talking about the interactivity of the system, like when you could edit the code that you were seeing, can you edit it in multiple type of views if they are implemented reversibly or something? I'm not so sure about the term, but because you can change the text of the code, but when there's a visual representation of it, can you make visual changes if you had some tools implemented for it?
Yeah, if you would have visual tools implemented for that, yes, of course you could. But you should also, I mean, of course, like it would be awesome to have everything be available in some graphical way that is completely intuitive. But that proved until now to have been a difficult problem to attain. But so what you're seeing here is that we do not need necessarily to have a fully visual necessary language or an environment in order for us to benefit from visualizations. We do not need to necessarily express the computation in a visual form. We can already extract a lot of value by just projecting the visualization onto an expression that was captured in some form. So code, for example, or text, or some JSON that comes. And maybe for the next 1 or 2 sessions, we're going to look at how do we, for example, work with a REST API or something, which is not even a programming language from that perspective, but it is like a programming because that means a function. So you call it and it does stuff. So what you're seeing here, this is like a middle ground on top of which you can actually build a visual language if you want, but you don't have to have a visual language for benefiting from the other from visualizations. So these are like a pragmatic approach that actually scales to many different problems without asking the systems to have been written in a certain form prior to the problem.
Cool.
Okay.
Yeah, thank you so much, Raphael, for the 2 questions. And that was a very great presentation, Tudor. Thank you so much.
Thank you, Adam.
Yeah, is there any other questions before I stop the recording? All right, so